1 second. Oh man, oh, it's big. All right. So I can't normally do this because this is in the observatory, but I have it in for cleaning and because I don't have it set up yet in the observatory. So today, we are gonna talk about this beast and what all I have attached to it, and yeah, kind of go over it. This is my telescope for those of you who don't know. Well, telescope and camera and a bunch of other things, but I want to talk about it, go over all the different parts, pieces, things that are attached to this behemoth, and hopefully teach you something. Let's go ahead and dive in. All right, so here is a general overview of this telescope. This is kind of what it looks like. But I want to go into the specifics here because I've never really done a video on from front to back what we're looking at here. So we're going to start on the front, and I do want to say a couple quick disclaimers. Number one, not everything is final here. So like you guys can see, I've got these kind of cable ties just chilling out. There's a big cable tie that I'm going to put around there. But anyway, there's some things that are not final, but this is going to give you a really good idea of kind of what I have attached to my telescope. So to start with, this is a flip flat up on the front. So let me spin this around. Oh my gosh, this thing's heavy. So right here on the front of the scope, this is called a flip flat, and it's from a company called Alnitak, I think. Not quite sure how you say it. You can buy it from optechinc.com, and I'll leave a link down in the description to this. But basically what this is it's a robotic, I say robotic kind of loosely here, it's a motor with a disc on it, and this disc can flip out of the way to allow the scope to see the night sky. And this serves two purposes. First is it's dust protection for the front of the telescope, right? When this flip flat is on here, we're able to keep dust from getting onto the front optic of the scope. Number two is it actually is a flat panel. So for those of you who don't know, in order to shoot flats, we need to take pictures of an evenly illuminated surface. Well, the back side of this evenly illuminates itself to a predetermined level, and my software can control that. And this basically becomes our flat panel. In fact, let me actually cut this off. I told you guys these cable ties are temporary. I want to show you what this really looks like. All right, so now that I've got this cut off, you can see a much better view. Basically, this side is a light. It's an evenly illuminated surface, and it will create light that the telescope photographs to create flat frames. So instead of having to use the dawn sky or use the white t-shirt technique, we're able to use this. And this whole thing, this little arm, flips out of the way to allow the front of the telescope to see the night sky when it's the time for it. This is normally attached to the telescope with a big cable tie, which I will do after this video. For now, I'm just gonna put this aside. All right, the next thing back is actually the telescope itself. This is the StellarVue SV80ST, I think. Anyway, it's an 80 millimeter objective telescope. It's got a 480 millimeter focal length, and it has been phenomenal. It's a triplet, it's super sharp. I have absolutely no complaints about this. Because it's a triplet, it does also need a field flattener, which we'll talk about kind of as we move to the back of the telescope in order to keep things sharp. But overall, telescope is great. So the next thing back from the front of the scope is this dew heater strap right here. And this whole purpose of this is it's just a heat strap to keep dew off the front objective of the telescope. This dew heater is one of two. There is another one over on the other side. Let me flip that around for you all. The other dew heater is right here, mounted to my guide scope. And now the front of the telescope is this direction. So I've kind of flipped orientation on us. And if we look, both of those dew heaters are attached to this little dew heater controller that I made, which is basically just a little 12 volt to dew heater controller. It almost just takes this kind of standardized plug type that most dew heaters use, and it converts it so that we can run it off of 12 volt. And we'll kind of explain the power system here in a little bit, but that runs in, and then I have these little knobs that you can turn and control in order to control the heat output to our different dew heaters. And this box right here was actually built by me. You guys can find instructions online of how to build dew heater controllers. You can also buy them. I just tried to do it on a budget. I like to do things myself, and this was one of those things that I built to be able to control this. All right, so moving on back, now we've got the top dovetail and the bottom dovetail. These are just standard dovetail plates. They're the Los Mandy style or the wider style dovetail plates. The reason I have two of them is the one down here on the bottom is what actually mounts to the mount, and the dovetail that's up here at the top is purely just for mounting additional equipment. It's really just there for extra kind of real estate to attach things. When you try to pack a bunch of stuff onto a small 80mm telescope, you kind of have to get creative, let's say, on how things are mounted together. And that all brings us to the top of the telescope, which is where two very important functions happen. The first is power distribution. This right here is simply a fuse block that takes the power coming into this whole setup and distributes it out safely to all of the different devices on the scope. The main power, which is disconnected right now, comes in right here. This is the input, and that has a 15 amp breaker on it or fuse on it. So basically, it will only ever pull 15 amps from the main power supply of the telescope. And then it branches out to these additional 1, 2, 3, 4, 5, 6 different circuits, you could say, or 6 different devices. And each device has a fuse for its given power needs. So you can see some 1 amp fuses, a 4 amp fuse, a 3 amp fuse, and those are based off of how much power each device on the scope pulls. So as a quick example, the filter wheel, which we'll talk about in a little bit, is at the very back of the scope, and it doesn't pull much power at all. So it has its own 1 amp fuse for the filter wheel. Basically, if the filter wheel were to ever pull more than 1 amp, it would mean something was wrong with it, and so we want that fuse to pop to prevent damage to the wiring or the hardware itself. The camera, on the other hand, draws a lot more power, so it has a 4 amp fuse, and so on and so forth. And basically, this just takes researching how much power each of your devices pulls and ordering fuses for each one. You'll notice too that there's one thing that's powered off of right here with a 1 amp fuse, and it runs right into this kind of beigey gray box down here. You'll also notice that all of these circuits run through this beigey box as well. What this beige box is it is a remote power relay. So essentially every one of these circuits on their way to get to their device, so this 4 amp, like I said, goes to the camera. Between this power supply and the camera, it feeds through this relay box. And this relay box gives me remote control to turn on or off the given device. And I know that that might sound confusing. I have other videos on my channel that kind of talk more about power distribution. And if this is something you guys are interested in, let me know in the comments. I'm happy to make a more detailed video. But essentially these two devices here give us both protection in the name of fuses and also remote power control through these relays here. And you'll notice that that Ethernet port right there is what gives us the local area network control over these different relays. And again, I've left links in the description to both of these products as well. Now, all of this is in the name of simple cable management. There are only 3 cables that need to run between my mount or my computer essentially and everything on the telescope. The first is a power cable, 12 volt power, which runs into this port right here. The second is an Ethernet cable, which runs into this port right here. And the third is a USB cable, which I'll show in a minute, where the USB data all breaks out. And just for clarity, here's a look at that other side with all of these different circuits feeding into the relay controller and then branching out to the different devices. You'll also notice that if we look down here, let me go ahead and rotate this around, bring you guys down a little bit more, we get our USB hub. So this is that third cable that's necessary. Right here, we plug our main USB cable going to our observatory computer in, and it branches out to these same 6 or 5 devices. You'll notice there's even power going into my USB hub here. That comes from the relay controller up above, because sometimes you need to restart your USB hub because of some sort of problems. So everything on this entire telescope is remote power controlled. We can turn it on or off from the computer. And that's simply because power cycling is such a good means of troubleshooting that it's so important to be able to have that control. From there, we have our 5 USB cables that go out to all of our different devices that are necessary to take photos. Okay, I think it's time now to talk about the imaging pathway, basically the path that light takes to get to the back of the telescope. So the light's coming in right here, it's passing through all of this. This is the filter wheel, and this blue thing off camera is the camera that accepts all that light. Well, in between that are kind of three very important things. The first is this blue thing, and this is the focuser. This is from a company called Moonlight Focusers. And it's fantastic because it's, for one, a really nice focuser, but for two, it can use this robotic or motorized focus controller. And you guys can see that. Here's the controller, here's the motor. And the whole purpose of this controller and this motor is to turn the focus and control my focus. Now, I can still undo a little clutch here and turn my focus manually if I want to. But the big advantage that this gives us is I can use autofocus in programs like Sequence Generator Pro or the like to control the focus on my scope without actually having to be in the observatory. So light comes through this focuser, then it goes through this guy, which is just a spacer, then it goes through this, which is a field flattener, a fourth piece of glass basically, because this is a triplet. It doesn't have a super flat field, so this field flattener corrects for that. It goes through a filter wheel, which I've made other videos about, which finally ends up in the camera, which is over here. This is the Apogee Andor U8300. It's based off the old Kodak 8300 chip. It's nothing to write home about, but it is a really good camera. I've really enjoyed what the 8300 can do. I know a lot of you are like, man, an 8300, that's ancient. It works for me. It does a good job. And you can see the filter wheel as well here is controlled by USB and power, and the camera also has its own USB and power as well. So just to give you guys a nice wide shot, here's everything, right? Telescope, front of the scope is up here, lights going through that telescope, through the focuser, through the field flattener, through the spacers, through the filter wheel, and finally into the camera at the back. You'll notice cable management, super important, right? I don't want things to get snagged when they're out there, so using this stuff called monkey wrap to keep everything kind of attached and nice. All of this just, trying to keep it organized. Even down to the point of circuit 1 on my power distribution block is the same device as USB 1 down here. So I kind of keep things the same. It makes it really easy in my head to be able to troubleshoot problems when the need arises. And for those of you who are interested, here's a close-up on the camera. You can see power coming into it, USB coming into it. This is an Astro camera, so for those of you who have more like DSLR or mirrorless experience, there's no screen, there's no controls, it's all controlled through the computer. There's no memory card slot, it's a tether-only camera, right? For those of you who've shot in the studio and you've tethered, you can only shoot this camera tethered to a computer. All right, and apologies, I've flipped everything around on you again. Now the camera's at the back on the left side, just for clarity. But I wanted to go over the last two elements of this build, which are the guide scope and guide camera, as well as this red dot finder scope down here. So you guys probably know what guiding is. This is just a super inexpensive QHY guide telescope with a QHY monochrome sensor or camera in the back. This is the QHY 5L-2-M, which has been great for guiding. And then this little guy is just a red dot finder, which I use for aligning the telescope and the mount when I need to build a new pointing model. And both of these are great. They've worked really, really well for me, but they kind of round off this whole build. And I should also remind you, right, part of this build is the flip flat, which we already talked about, but that kind of completes the whole setup. So I feel like I just need to clarify a couple of quick things. Number one, this will seem pretty overwhelming for some of you who are new to this hobby. And I want to tell you guys, I started astrophotography in 2013 and it's now 2022. So I've had almost 9 years of doing this and building out this kit. I also want to point out I'm a little bit of a gearhead. I love this stuff. I nerd out on all of these crazy things and tools and pieces of equipment, how they all connect and all that. I just love this stuff. I love wiring. That's why I have, all this custom wiring jobs. I adore this type of thing. So I want to make that clear. The second thing is astrophotography is inherently a very gear-centric hobby. So keep that in mind. If you're somebody who is more about the art of photography. Astrophotography is a lot about the science and the equipment. It just is. So that's something to kind of go into this hobby understanding and knowing. I guess the last thing that I would say is if you guys are trying to build something like this, I would never recommend building this all in one fell swoop. I wouldn't just go to OPT's website or B&H's website and order every single thing that I just showed, because this is gonna be incredibly difficult to learn all at once. These are stepped steps. They're steps, right? They're things that we want to slowly add on as time goes on. Like, ooh, okay, I got the hang of a telescope. Let's now put a dedicated astro camera on the back of it. Okay, I got the hang of that. Let's put a filter wheel on it. Okay, I got the hang of that. Let's add guiding. On and on and on and on and on. It's an iterative process. So keep that in mind as well, because this would be overwhelming for anybody who, if they were to just get all this at one time and do it. So anyway, I hope you guys liked this video. I wanted to do an overview like this for a really long time, and I finally had the scope inside, so I figured it was a good time to do it. If you guys have any questions, leave them down in the comments section down below. Hit the like button if you liked this video or got some knowledge out of it. And lastly, hit subscribe if this content interests you and you want to stay up to date with future videos. Thanks everybody. Woo!